Welcome to this video. In this video, we'll talk about data transformation. Many often the data we have is not the data we want to visualize. Thus, we often transform our data in order to create the visualization that we want. So far, we have been doing this step using pandas, but also Altair provides different ways of creating data transformations. Let's take a look at this new dataset. This new dataset contains information about movies. There are some information about the movie, including the type of the movie, director, distributor, as well as the genre, budget, release date, title. But there are also review ratings information from different sources, including from IMDb, MPAA, as well as Rotten Tomatoes. We'll start talking about histograms. Now, before talking about histograms, let's take a look at this scatter chart. The scatter chart shows the distribution and relationship between ratings on IMDb and ratings on Rotten Tomatoes. We can see that in general, there is a linear relationship between the two ratings. The higher one rating is, the higher the other rating is. But we have no idea as how those ratings range for several movies. So we want to create a histogram, and the idea behind a histogram is that we want to plot the frequency of different categories in our data. Now, these categories can be the ratings themselves, but the ratings themselves may not be discrete numbers. Indeed, if we take a look at this data, you can see that it's possible to have a rating which is not a whole number. So let's take a look at creating histogram when our data is not in nice categories. What I'm going to do here, I'm going to create a bar chart. So I'm going to mark bar, and I'm going to encode my X to be the genre for now. I'll get to that in a minute, and my Y to be the count. That basically will be the count of movies in each genre. I'm just going to double check the column name. I've probably misspelled it. It's major genre in this case. Let's go back to this bar chart, and you can see that here I have the frequency, which is the count of movies in each one of these genres. So far so good. So how about if I, instead of doing genre, I use one of the ratings? So for instance, let's do the IMDb rating. I'm going to do so here, and I've got something like this. Now, while this may be okay for this dataset, you can see that there are so much variance in the ratings. For instance, between 2-star and 3-star, we have so many ranges, and usually those different counts in these different ranges are not important to us. We're really interested in movies that have 1, 2, 3 to 10 ratings. So we need to combine this data somehow in order to group all of the observations that have 2 to 3, 3 to 4, 4 to 5, 5 to 6, and so on. We can do this using pandas. So using pandas, we can use categorize different observations based on the ratings in different categories. We can write our own function to do this, or we can use a built-in function called cut to bin the data. So the idea behind cut is that it creates discrete categories from continuous categories. Let's take a look here at movie Rotten Tomato ratings here. That's a series, and you can see that it has a range of values. You can actually describe it here. To take a look at the range of values, ranging from 1 all the way up to 100. Well, okay, I mean, this is a large range of values, but we want to categorize this. So the function cut, pd.cut, can create discrete categories from continuous values. So if I cut this series, I can specify how many bins I'd like to get. Let's say I want to have 3 bins. I get the bins from 0.901 to 34 and 67.0 to 100. as well as a third bin that doesn't show up here. So I can put unique probably to see the unique values. And the third bin is 34.0 to 67. So each observation, as well as the null value, which has been kept as a null. So I've got 3 bins here, and the function cut will automatically determine the binning based on the distribution of the data. And this function also provides different range of options in order to kind of fine-tune the binning itself. Now, if I create 10 bins, I'm going to get 10 bins here of the data itself. Okay, so what I am doing here, I'm binning the data. I'm creating a new column called bin rating based on binning the data. And instead of having the whole bin information, I'm just substituting and taking the midpoint of that bin. Let's drop the null value and take a look at the binned value here. The bin rating is, as you can see here, we've got 20 of these bins here, and those are the rating associated with these bins. Next, what I'm going to do, I'm going to manually count these bins by grouping by bin rating, getting the title, count, and reset index. And I've got the counts of each title in each one of these bin rating. And finally, I can go to Altair, pass my new data frame, mark bar, encode, X is the bin rating and Y is the title. Notice I don't need to count or anything because I've done all of my data transformations in pandas. This will create a histogram that looks like this. So this is definitely possible to do our data in transformation in pandas, which is actually not a bad idea if the data transformation is involved. But for many of the very common data transformations, Altair provide a built-in way to do the transformation, so we don't need to do the extra step of going back to pandas. Let's take a look at creating this histogram using Altair. So let's start by creating a chart using the using the circle graphical mark. I'm going to encode X to be the Rotten Tomato rating. Let's actually take this parameter for now and see what we get. And the second one is going to be the IMDb rating. Sorry, the second one was going to be the IMDb rating. I got the scatter plot here as in before. Now notice if I provide bin is equal to true, this continuous value, ranges of value on the x-axis is going to be binned in discrete bins. So we've got bins here instead of the whole ranges. We can actually do the same thing on the y value. We can do bin is equal to true and you get discrete bins instead of a range of values. Okay, we will return to this example later. This example is starting from a scatter plot. So I'm going to just leave it as is for now, and we will get back to it. But we can apply the idea of binning to create a histogram. Now, what I'm going to do, I'm going to create a bar chart using the bar graphical mark encode. And then I'm going to make my X to be the rating, Rotten Tomato rating, and Y to the count. That's what we have done above. If I take bin here, you notice that I got the same histogram that I got above. The only difference here is that I'm going to tell it to bin the data. So when I tell it to bin the data, it's going to collapse close observations into discrete values. And of course it has some default values. It's going to create 10 bins for me, which may be good for this particular purpose, but we have options to change that behavior. For example, if I want to do 20 bins, I'm going to do bin, and instead of equal to true, I'm going to use the function bin parameters. Maximum bins is equal to 20, and I'm going to get 20 bins here. That's kind of similar to doing the cut function in pandas and then going and visualize the data. This is doing the binning within Altair. Now notice here that we have two data transformations. There is the binning, which is transforming the data on the x-axis, and there is count, which is transforming the data on the y-axis, right? So that's the count of observation in each bin. This is a similar histogram. The only difference is that I'm looking at the IMDb rating rather than the Rotten Tomato rating. And you can see that the IMDb rating is kind of more concentrated, around 6.5 to 7, versus the Rotten Tomato rating, which is all over the place. So although in general those two ratings go together, the IMDb rating is much more consistent. There are a few movies that get very low rating or very high rating, whether in Rotten Tomato we have many more movies in extreme ratings. Let's go back to the example of the scatter chart. And here my X is Rotten Tomato rating, my Y is IMDb rating, and what I am doing, I am binning both axes. So what I get here, I get circles on both axes. Now that's not very useful. It basically shows that there are observations in these combinations of those bins. What will be useful is to make these circles proportional to the number of observations, which is what I did here. I used another encoding channel, which is size, to be the count of observation. And now each one of these circles corresponds, the area of each one of the circle corresponds to the number of observations here. So we can see that in this case, there are many kind of movies. We can see the linear relationship between the two ratings. And we can see that although in general there are combinations of, low in the extreme values, the number of these combinations is much lower than the number of combinations in similar ratings of the movies. What I am doing here, instead of using circle, I'm using a bar, a graphical mark, and instead of using size, I'm using color. What I get here, I get what we call a heat map. Basically, each one of it's kind of like a two-dimensional histogram, three-dimensional histogram. But instead of plotting in 3 dimensions, you can imagine this like as 3-dimensional bars. It basically uses color to communicate the 3rd dimension. So in this case, we can see the concentration of common combination of the values of IMDb rating and Rotten Tomato rating. Notice that the value of binning is really important here. If I don't use binning, I'm going to get a very sparse heat map, which is really not what I'm looking for here, because I am really looking for kind of a discrete heat map. So counting is one data transformation, binning is another data transformation. In the past, we looked at average. Here are some of the common data transformations available in Altair: average, median, min, or max. So let's take at average. We looked at average. Say, for instance, we want the average rating per each genre. And we plot this. We can get a bar chart here, right? And the height of the bar is the average rating per genre. Notice that Altair also kept the null values here. Now, this bar chart can be improved if we can sort the bars to start from the highest rating to the lowest rating. This is a sort transformation. We basically want to sort the data based on a value. And this value is the average Rotten Tomato transformation. If we take a look at the y-axis is the measured genre, but there is an extra parameter here to specify the sort on which the y-axis is sorted. And it is sorted by encoding another field. And that's the transformation that we're doing. We're basically taking average, applying it to the field Rotten Tomato rating in descending order. So what we get in this case, we get a sorted y-axis on the average Rotten Tomato rating. Let's take a look at some more data transformations. Median and interquartile range. Those are useful to show the ranges of the data. So the median is the data point for which half of the observation are smaller and half of the observation are larger. And the quartiles, the first quartile is such an observation, such as 25% of the observations are smaller, 75 are larger. And the third quartile is a point for which 75 of the observations are smaller and 25% are larger. Those values are useful to show the range of the data as well as the existence of outliers, very large or very small values. So instead of using average, I'm going to use the median, and the idea here is that the median is less sensitive to outliers. So what I get a similar bar chart, but the size, the height of the width of the bar in this case is much less sensitive to outliers. Let's do average here. I'm going to do average for a second, and you can see that it will vary more when we do the average. Alright, so we've seen how we specify the X and X2 encoding channels for the bar chart, and this will basically create a bar that ranges from two values. In the past we used min and max, but min and max also depend on the outliers. If somebody rated a movie at 0, that will make the whole rating, the minimum rating of a certain genre, to be 0. We want to be less sensitive to such outliers, so instead of using min and max, we're using Q1 for the first quartile and Q3 for the second quartile, for the third quartile. The second quartile is the median itself. And we are sorting across the median. So what we get here, we get a bar chart that shows the ranges of ratings across these different genres. Let's say we want to show the median on the top of this chart. What I'm going to do, I'm going to create another chart, and I'm going to use the tick graphical mark to show the median. That's basically the same specification, except that instead of using bar, I'm going to use tick, and I'm going to make the tick red, otherwise it doesn't show up because it will be blue. I don't have an X and X2 for a tick, I only have X, and the X will be the median of the rating in Rotten Tomato. Notice that the plus operator is going to combine the two charts. So now I have the two charts overlaid on top of each other, and I can see the ranges as well as the median of these ratings. Finally, let's talk about time units as well as time transformations. So what I'm going to do here, let's actually just create a time chart. So in this line chart, I'm going to encode my X to be the release date and my Y to be the number of movie released. Okay, so as you can see here on the X-axis, we've got the release date. And there are a couple of things here. One of them is that the release date is treated as an ordinal variable. Right? We've got a bunch of discrete values, and each value is put on the axis. And even worse, the gap in between the two values is not proportional to the distance, the date difference in between these two values. Indeed, even worse, these values are not sorted, they're ordinal. So we got completely meaningless graph here. How do you deal with this problem? Well, underlying this problem is that if you take a look at the D types in movies, you can see that the date itself is an object. It's basically a string. So Altair doesn't even recognize it as a date. There are two solutions here. One of them is to fix it in pandas, and the other one is to fix it in Altair. To fix it in pandas, we need to convert this from being a string to being a datetime object. So what I'm going to do here, I'm going to create another column. I'm going to call it RD just to illustrate the point here. I'm going to use a function called toDateTime, and I'm going to pass movies release date. Now, if I repeat the D types again, I'm going to see that RD is a datetime object compared to release date with an object. So instead of release date, I'm going to put RD here. And as you can see here, now the date has been captured correctly. So we can see that the number of releases vary. That's a very jagged line. One of the issue obviously is that it's some of these dates, there is like very little movie released, like one. So the line is very jagged. It makes sense to aggregate this data. So probably we want to count per months, year, quarter. And we can do that obviously in pandas. Altair provides similar date transformations. Let's take a look. Instead of using the toDateTime function in pandas, we can actually use a time data type. So if I put release date, now it's been treated as an ordinal data type. If I make it time, :t, Altair will transform it to a datetime data type, which is important here. So that figure now is meaningful. It's not just because the x-axis is now sorted, but it also opens an opportunity to do some data transformations. For instance, I can group by year here and count the number of observations per year. We get something like this, which is a more meaningful figure here. So we can see an increasing number of movies released in 2000 and then going down afterward. I'm not sure about this part of the line. It seems they have some data issues. It looks like we have movies released in 2020, 2030, 2040. That's something we need to investigate in the data itself. Okay, so let's take a look now at this chart here. It's an area chart, very similar to the first one. Instead of a line, I'm using an area. I'm grouping by the months on the x-axis. On the y-axis, I'm plotting the median, the gross, in the US, the gross income of that movie in the US. Now notice that the year here is not included. It's just per month, so I can see that summertime brings much more profit to the movie industry, and also just the holiday season. Let's take a look at this example. That's very similar, but instead it uses worldwide gross income, and we can see similar pattern here. So this concludes the presentation of the different data transformation in Altair. In general, it's possible to do our data transformations in pandas prior to using Altair. At the same time, we want to shortcut many of the data transformations that we do in pandas may be a bit time consuming, and we want to be able to create charts in a much more kind of interactive fashion. The option is yours. If you feel more comfortable using pandas, go for it, but Altair also provides some built-in data transformations.